Right, so we are going to do the iGCSE 2H higher tier paper. This morning we're going to work through the solutions. I hope you find it useful. Expand and simplify y plus 4 2 minus y. You've just got to make sure you times everything by everything, so whatever systematic way you have of doing that. We're going to go y times 2, that's 2y, 4 times minus y, that's minus 4y, y times minus y, that's minus y squared, and 4 times 2, that's positive 8. So we tend to, we've got to combine the y's together, so that's minus 2y minus y squared plus 8. We tend to put the positive thing first and not begin an expression with a negative, so 8 minus 2y minus y squared. But equally, any order, as long as you've got a minus y squared, a minus 2y, and a positive 8, you're all good. Okay, the next one, fully factorise. Fully factorise. That means you need to take the biggest thing out the front. So we're going to look at the biggest number we can take out. So the biggest number between 15 and 35, that's going to be 5, because this is just 5 and 3 doesn't go into 35. So 5. Biggest number of b's, b cubed, and the biggest number of c's, so that's c, just one c. And what's left to be able to make this? Well, I need a 3 times 5 is 15, I need another 2 b's, but I don't need any c's. And then to make the other one, I need 7 times 5 is 35, b cubed, so I don't need any more b's, but I need c to the 8. There we go. Next one is a show that. So show that divided by that, so the working is key. How do we divide that? Well, the first thing we need to do is convert it into a top-heavy fraction, so 6 fours are 24, that's 24, 25, 26, 27, so that's 27 quarters divided by 14, 18 sevenths, and that is the same as, so dividing is the same as multiplying by the reciprocal, so multiplying by the fraction turned upside down. Some people call this copy, kiss, and then flip. Okay, but we're multiplying by the reciprocal, so the same as it kind of comes from dividing by half is the same as multiplying by 2. Okay, it's the same concept. So we then can see whether we can cancel anything, and we can see that a 3 goes into the bottom here, so 3's into 18 is 6, 3's into 27 is 9, and then we can multiply that together. 9 times 7 is 63, it's 24, and another 3, I could have got another 3 out of that, but I can cancel it now. 3's into the top and bottom, 3's into the bottom go 8, 3's into the top go 21, 21, that's 2, and 16, so that's 5/8. Okay, And you can see that that's what we've got there. Always reassuring those ones that we know we've got it right. Okay. So, got a couple of similar triangles. Triangle ABC is similar to, that means there is an enlargement factor between them. Calculate the length of BC. Okay, so we need to look at what the enlargement factor is. Well, if they are similar in this order, which you can see from the corresponding angles, so that one and that one, they're the same, and this one, they're the same. Therefore, it's similar in the orientation that is drawn. So we're looking for the enlargement factor. Well, we're looking for the common lengths. So there to there is the enlargement factor. So the scale factor equals 12 divided by 4 equals 3. So the length of BC, so we want to go back from here to here, so we're going to divide by 3. So BC equals 16.5 divided by 3 is 5.5. Write down an expression for y in terms of x. So that's just the link between y and x. So y is 3 times x, because the scale factor is 3. Okay, question number 4. Each of a regular side of a octagon has length 18 millimeters. Correct the nearest 0.5 millimeters. Write down the lower bound for the length of each side. So it's correct to the nearest 0.5 millimeters. Okay, so to the nearest 0.5 millimeters means that the lower bound is going to be half either side of that. So it's going to be 17.75. That's the lower bound, and the upper bound would be 18.25. Okay, because if it was closer than that, then to the nearest it would be 17.5 if it was any lower than that. Okay, to the nearest 0.5. Write down the upper bound for the length of each side. So I've already mentioned that is 18.25. So it's just half the thing either side. Okay, question 5. Now, the scale of the diagram shows the position on the map of house A. Here's a house, it's on a bearing of 110 degrees from A. The distance from A to C is 700 meters. Mark this with a cross. Now clearly this is more difficult for me to kind of do and check that you're getting right, but let's just check we're measuring the angles in the right place. So we've got 110 degrees. So 110 degrees. degrees is going to be over here. So there's me measuring 100 degrees. I've gone clockwise 110 degrees. You're allowed to be a degree out either way. And then you've got to get the distance right. It's 700 meters. 1 centimeter represents 200 meters, so that's 3.5 centimeters. Now, I'm going to slightly be making this up because the scale is, but let's say it's there. Mark with a cross C, and that would be 3.5 centimeters. So 700 meters. So do just check that you've got 3.5 centimeters there. And then part B, write the scale of the map in the form 1 to n. So we know that 1 centimeter is 200 meters. Now, to be in the form 1 to n, we want the units to be the same. So let's turn them all into centimeters, and we've got 1 centimeter is 200, and then there are 100 centimeters in a meter. Centimeters. So that means the actual ratio is 1 to 20,000. So 20,000 there. Okay. Next one. Put a probability. A bag contains only pink sweets, white sweets, green sweets, and red sweets. The table gives the probabilities that when each sweet is taken at random, the bag will be given a green sweet or the sweet will be red. 0.2 and 0.35. The number of pink sweets to the number of white sweets is 2 to 1. There are 28 sweets in the bag. Work out the number of white sweets in the bag. So the number of pink sweets is twice the number of white sweets. So if I say this is just going to be 2x, this is x, so we've got the probabilities 3x plus 0.2 plus 0.35. That's got to equal 1 whole one. So we know that 3x, and I should really say let x be the probability you pick a white sweet. So 3x is 0.45. Taking both those away, that's 0.55, so 0.45. So x is 0.15. Then it says there are 28 red sweets in the bag. So the total number of sweets in the bag is 28 divided by 0.35, because 0.35 times the number of total number is, so 28 divided by 0.35 is 80. So there are 80 sweets in the bag. So the number of white equals 0.15 times 80, which is 12. So there are 12 white sweets in the bag. Question 7. The lowest common multiple of these numbers. So the lowest common multiple. So the easiest way is to write it down in terms of the prime factors. So then you don't miss anything. So this is 2, 14, 2, and 7. So this is 2 times 2 times 7. So that's that one. 42 is 2 and 21, which is 3 and 7. Excuse me, 2 times 3 times 7, and then the last one is 63. There's no 2's in it. 3 and 21, 3 and 7. So that's 3 times 3 times 7. So the lowest common multiple means that I must have, I must be a multiple of this. So I must have a 2, a 2 and a 7 in it. I must have a 2, a 3 and a 7 in it, and I must have a 3 and a 7. So overall, what's the lowest number I need? Well, the lowest number of 2's I need is 2 2's. The lowest number of 3's I need is 3 3's. And the lowest number of 7's I need is just 1. So the lowest common multiple is just those things multiplied together, which is 2 times 2 times 3 times 3 times 7, which is 252. Question number 8. The table gives information about the average house price in England in 2018 and 19. Work out the percentage increase in average house price from 2018 to 2019. So percentage increase, so we want to know the increase. So the increase is 231,776 minus 228,314. 231,776 minus 228,314. 3,462, and we just need to put that over the original price. So it's always over the original. So from 2018 to 2019, the original price was the 2018. So it's 3,462 divided by 228,314. That's a fraction, so turn it into percentage by timesing by 100. At 1.5%. One decimal place, so let's just, this is 1.516, so to one decimal place that's 1.5% to one decimal place. The average house in 2019 was 7.7% greater than the average price in 2017. Work out the average house price in 2017. So I'm going to say the price in 2017 I'm going to call X. And if I'm going to add on 7.7%, I'm going to times it by 1.077, and I'm going to tell you that that is the house price in 2019, because that's what it tells me. Which means X is just going to be that divided by 1.077, so 231776 divided by 1.0 is 215,205,1996. And it says, can you give this to three significant figures? So three significant figures is 215, and then the rest have got to be zeros, because then they are not significant. Okay, so 215,000. So be careful, it's all about doing the percentage on the original, and in this case the original is the thing that you don't know, so hence putting an X can be helpful there, helping to understand that. Okay, let's move on. Okay, work out the value of X. So the mean number of points scored is 2. So how do we work out the mean? Well, we add up the total number of points. So the total number of points is 13 times 0 plus 1 times 17 plus 2 times 8 plus 3 times X plus 4 times 11, and then we divide that by the total number, so that's 13 plus 17 plus 8 plus X plus 11, and that's got to equal 2. Okay, so I've got to tidy that up. 13 times 0, that's fine. 1 times 17, that's 17. So 17 plus 16 plus 44, so that's 77 plus 3x on the top, or on the bottom, 13 plus 17 plus 8 plus 11 is 49 plus x equals 2. So then multiply by the bottom, 77 plus 3x equals 2, 49 plus x. So I'm multiplying both sides by 49 plus x. On the left hand side it cancels, on the right hand side we just put it like that. So 77 plus 3x equals 2 times 49, which is 98, plus 2x. Take the x over to that side, x, take 77 off that side, and we've got 21. So x is 21. Okay, now a bit of simultaneous equations with some decimals, but we just work about it in exactly the same way. So how are we going to do this? I think the easiest way is probably to double the top one and then subtract them, and that eliminates the x's. Okay, so I'm going to double the top one, so the top one becomes 6x plus 10y equals 6.2, and then I've got 6x plus 3y equals 3.75. So I'm going to subtract the bottom one from the top one. 10 minus 3 is 7y. 6.2 minus 3.75 is 2.45. So then y dividing by 7 is is 0.35. And then I put that back into the other to another one, so I've got 3x plus 5 times 0.35 equals 3.1. So I've got 3x equals 3.1 minus 5 times 1.35. Divide that by 3, and I've got x is 0.45. Now I'm going to check that in the other one. 6 times 0.45, so this is my check. 6 times 0.45 plus 3 times 0.35, and it should be 3.75. 6 times 0.5 plus 3 times 0.35 is 3.75. So that's a really nice one when you get to the end of that, because you know you've got it right. Let's just make it really clear for the examiner and put our answers on the line. 0.45, y is 0.35. Diagram shows a 10-sided polygon. Show that x equals y. Okay, so we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we've got two five-sided shapes here. So what we're going to do is, first of all, we're just going to work out what each interior angle is, because I can't see exactly how this is going to work. So the exterior angle which, if we just do it on one over here, is going to be 360 divided by 10, which is 36. So the interior angle is 180 minus that, which is 144. So that means that each of these is 144. And then I think probably the easiest way is to show by symmetry angle HGA equals angle GAJ. So that's these two. This is a 1, 2, 3, 4, 5-sided shape. So 5-sided shape is 3 triangles, so a pentagon sums 80, which is 540 degrees. So we've got angle, so x equals, so that and that are both x, so x equals 540 minus 3 times 144 divided by 2, because there are two of those x's. So 540, 3 times 144, 108 divided by 2, it's going to give me 54. So if that's 54 and 54, so that means that this is 180 minus 54, so this one is going to be 90. And let me go in here, so that's 144, that's 144, so we need a bit more space. Let's just do it down here. So I'm going to call that angle W, this angle W. So 2W plus 144 plus 144 equals 360. So now that's a quadrilateral, therefore W is going to be 360 minus 144 minus 144 divided by 2. So W is 36. So Y is then 144 minus 54, so that's for x, minus W, which is 36. 144 minus 54 minus 36 is 54, hence x equals y. Now there may well be much simpler ways of doing that, but that's what occurred to me. If you're not sure whether what you've done proves it, then do talk to me. 6 times 10 to the 40 to the power 3. So that's 6 to the power 3. 6 times 6 times 6, so that's 216 times 10 to the 40, which is 10 to 120. But this is not in standard form because this first number has got to be less than 10, so that's got to be 2.16. So we've now, to make that equal, we've divided that by 100, so we've got to multiply this by 100, which means we want an extra 2 tens. So we've got 2.16 times 10 to the 122. Down 3 inequalities that define this line. The equation of one of the lines is given, okay, so we need to know the equations of the other line. So we've got this vertical line, this one here, so this is the line x equals minus 1. This line here is 1, 1, 2, 2. This is just the line y equals x. And which side do we want to be? Well, the x's, we want the x's that are bigger than minus 1. So one of them is x is bigger than, it's a solid line, so equal to minus 1. this one, we want the y values, we've got to be bigger than the x values because we want to be above this line. Y is bigger than or equal to x. And this one, well, the way I do it is I pick a number down here to see which way. So I want this point to be in my region. So when x is 1 and y is 2, I want that to be in my region. So when x is 1, y is 2, so this is going to be 1 plus 2 times 2 is 4, 5. 5 has got to be something 8. 5 has got to be less than or equal to 8. So I know it's got to be x plus 2y. It's got to be less than or equal to 8. And I can actually check this point with all of them. Is 1 greater than or equal to minus 1? Yes. Is 2 greater than or equal to 1? Yes. So that point works for all the inequalities. So there are my 3 inequalities. Okay. Zip wire is shown as the dashed line AC in the diagram. Zip wire is supported by 2 vertical posts on horizontal ground. Zip wire makes an angle of x with the horizontal shown. The design of the wire requires the angle to be at least 5 degrees. Work out the least possible height of the post and give your answer to 3 significant figures. So you've got that little right angle triangle there. It's 5 degrees. This is 12 meters. So we've got this sort of triangle here with a 12 there and a 5 there, and we're trying to work out this length here. So we've got the opposite and the adjacent. So we know that the tan of 5 equals the opposite, which is h, over the adjacent, which is 12, which implies that h has got 12 times tan of 5, which is 1.0498. So that's this h here. So AB has got to be the 2.6 pole plus 1.0498, which to 3 significant figures is 3.65 to 3 significant figures. Okay, the Dare recorded the distance in kilometres he cycled each day for 11 days. Here are his results. Find the interquartile range. So the interquartile range, we need the upper quartile and the lower quartile. So the middle one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the middle one, we don't need this, but just to remind you, so the median is the 11 plus 1 over 2 is the 6th value. Okay, now you can do that from just crossing in from either side. 1, 2, 3, 4, 5 on that side, 1, 2, 3, 4, 5 on that side. You get 23, oh, except we haven't put them in order yet. Okay, it's the 6th value if I put them in order. Okay, the lower quartile is the 11 plus 1 over 4, which is the 12 divided by 4, which is the third value. And then the upper quartile is the 3 times that value. So is 3 times 3, which is the 9th value. Okay, but I've got to put them in order, so let's do that. So we've got 5, 5, 7, 8. Notice I'm crossing them off as I go, because otherwise this is actually really hard. 10, 12, 13, 14, 16, 21, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the third value is 7. 11, 10, 9th value is 16. So the interquartile range is the 16 minus the 7, which is 9. It's interquartile range, so that's the middle 50% of the data takes a range of 9, because you've got a quarter of the data up here, a quarter of the data up here, the middle quarter is in there, and the range for that is 9. So there's my answer. Okay, D, E, F, and G are points on the centre of a circle. EOG is a diameter. Calculate the size of angle DFG. DFG. So we're wanting this one in there. Okay, so what we're going to do, we're going to write down what we know. So it's a diameter, so we know that angle EDG is 90 degrees. Angle from a diameter equals 90 degrees. That's my first reason, so that one's there. Then angle, this one here, angle DEG equals, that one equals 48. And the reason is angles in a triangle, you see the triangle DEG, triangle equal 180 degrees. And then you can see that those two are the same, so angle DFG equals 48, and this is angles in the same segment are equal. Don't think you can do it in less than 3 steps, but if you want to check that with me, by all means check that with me. And you've got to give all those reasons to be able to get that. DFG is 48 degrees. Okay. Show that this can be written in this form. So this is a little trick. It's called rationalising the denominator. So we want to get rid of the surd on the denominator. So we want to multiply by something, and the trick is we're going to multiply by root 3 minus 2. And the reason is because of the difference of two squares thing. That so we've got to multiply the top and bottom by that. When we do this, we do root 3 times root 3. So if I'm going to just get the bottom here, root 2 times root 3 is 3. And then 2 times minus 2 is minus 4. But then we've got 2 times root 3, that's positive, 2 root 3, and then minus 2 root 3. So we've got nothing else on the bottom. So the bottom has been rationalised, which is what we're trying to do here. Then we're going to multiply at the top. Root 12 times root 3 is root 36, which actually we can see is 6, minus 2 root 12. Okay, so let's just do that. So root 36 is going to be 6 minus 2 root 12 over minus 1. Okay, so the minus 1 mean we get minus 6 plus 2 root 12. But it says very particularly it wants it as the square root of one number. Okay, so we've got to bring that 2 inside the square root, so that is the same as 2 squared inside the square root. So we've got minus 6 plus root 48. So we're going to bring the 2 inside, it becomes 4, so that's root 48. So we've got minus 6 plus root 48, and that's then in the form that they are asking it for. Okay, prove that when the sum of the squares of any two consecutive integers is divided by 8, the remainder is always 2. So, two consecutive odd numbers. Well, let n be an integer, then 2n plus 1 is an odd integer. Okay, so that's guaranteed we've got an odd number there. Two consecutive ones, then 2n plus 1 and 2n plus 3, or we could do minus 1, are consecutive odd integers. And then we've got to see when we divide that by 8. So let's just, the sum of the squares, so we've got to do some summing and squaring. So sum and squared, so we get 4n squared plus 2n plus 2n plus 4n. I'm doing this in my head, but you can multiply it out by 2 in 2 brackets, plus 4n squared plus 6n doubled is going to be 12n plus 9. So altogether I've got 8n squared plus 16n plus 10. So now I'm going to divide this by 8. 8, get 8 brackets n squared plus 2n plus 1 plus 2. remainder when divided by 2 divided by 8 is 2. There we go. Let's keep going. On to the final row. Calculate the radius of the circle. PTQ is the diameter of the circle. RTS is a chord. Okay, and we know that we call this x. We know that 4 times 12 equals 3 times x. So this is 48 divided by 3, so x is 48 over 3, which is 16. So we know that PTQ equals 16 plus 3, which is 19. So the radius, and that's the diameter, is 19, 2, which is 9.5 centimetres. Hopefully you managed to do that. That was the topic we did at the beginning of term. Okay, the histogram gives information about the heights, H of some tomato plants. There are 12 tomato plants, for which 75 to 85. So the thing we need to know with a histogram is that it is the area that gives us the frequency. So 75 to 85. So 75 to 85. That's going to give us 12 tomato plants. So that's 10 wide. So the height here is 1.2. The height there is 1.2. So let's just figure out what the scale is. So I think that's 24 little squares. So I think that's 0.5. And then that's 1. And then that's 1.5. And that's right. So then that one above will be 1.25. Yeah. So we've now got the scale sorted. So now we can say that height of that one, because we want greater than 82.5, so we need to know that the height of that one there is 0.4. Okay, so we can then do greater than 82.5, so 82.5 is sort of there. So we've got 2.5 up to 85, so we've got 2.5 times the height of that one, which we now know is 1.2, plus the width of this one, which is 85 up to 90, which is 5, times its height, which is 0.4. So 2.5 times 1.2 plus 5 times 0.4 is going to be 5 overall. And we want tomato, probability the tomato plant, probability, so we want to know how many there are altogether. Okay, so it's 5, so there are 5 bigger than there, and then altogether we've got 5 times 0.6 plus 10 times 0.8 plus 5 times 1 plus 10 times 1.2 plus 5 times 0.4. So 5 times 0.6 plus 10 times 0.8 plus 5 times 1 plus 10 times 1.2 plus 5 times 0.4 is 30. So altogether 30. So the 30. So the probability equals 5 over 30, which equals 1 over 6. There we go. So the key to that one was getting the scale right, and then it's actually relatively straightforward. Okay, part of the graph is shown. Use the graph to find estimates to the solution 2x squared minus 4x minus 1 equals 0. Yeah, so we want to know when this is the same graph that we've got here, so when does it equal 0? Well, it's here and here. So reading the scale really carefully, I make that x is minus 0.2 and positive 2.2. Don't think you can get anything else more accurate than that. So we're just using the graphs. We don't have to do any calculate. By drawing a suitable line on the grid, finds estimates to the solutions of this. Okay, so we want to know where x squared minus x minus 1 equals 0. But we don't have that equation. We have the equation 2x squared minus 4x minus 1 equals 0. So we're only allowed to draw a line. Okay, so if we double this one that we've got 2x squared minus 2x minus 2 equals 0. So the solution's the same as finding that. And then what have we got to do to both sides to get one side of the equation looking like this one? Well, if I subtract 2x and I subtract 1 from both sides, add 1 to both sides. So subtract 2x and add 1 to this side, I do it to this side, then solving this original equation is the same as solving this equation and is the same as solving this. Okay, because I've doubled both sides, so that's fine, and I've subtracted 2x and added 1 to both sides. So these three all give the same solutions. Now the advantage of this one is that I've drawn this, and so if I draw this, then that is the same as finding those solutions. So I'm going to draw the line minus 2x plus 1. Minus 2x plus 1 it's going to go through 1, and it's minus 2x. So along 1. Along 1 down 2. Along 1 down 2. Along 1 2 now. Okay, so you should be able to get this more accurate than me. I'm going to draw a line in there. There we go, and we're going to look at the x values of solving this, which I make 1.6 and minus 0.6. So we've got 1.6 and minus 0.6. There we go. You may want to ask some questions about that, but that is how we do it. Question 22. Here is a rectangle. Given that the area of the rectangle is less than 75, give the range of possible values of x. So we know that 2x plus 3 times x minus 1 got to be less than or equal 75. Oh no, less than or equal to, less than. So we multiply that out. So we've got 2x squared plus 3x minus 2x minus 3 is less than 75. So we've got 2x squared plus x minus 3 minus 75 is minus 78. It's less than 0. Okay, so we now might be able to factorise that. 78 doesn't seem like a very nice number. 39, 13, don't know. So I might put that into my formula. X equals minus b plus or minus square root. So I've got x equals minus b, which is minus 1, plus or minus the square root of b squared, which is 1 squared, minus 2ac, which is minus 78, all over 2a, which is 4. So it's going to be minus 1, plus or minus 1, sorry, 4ac is plus minus the square root of 625 over 4. Square root of 625 is 25, so I've got minus 1 plus 25, which is at 24 over 4, which is 6, and minus 25 is going to be minus, say 25, 1 minus 25 is minus 24, minus 24 divided by 4, no, 26 divided by 4, sorry, is minus 6.5, but it can't be a negative number. And in fact, the lengths can't be negative numbers, so the smallest x can be is actually 1. So actually, x is bigger than 1, but less than 6, because it must be between those two values. Okay, so the other thing is the lengths can't be 0. Little one there. 23. Okay, the diagram shows triangle. Work out the area of the triangle PQR. Here. So we really need to work out this length here. So we're going to work that out using a bit of cosine rule. So we know that a squared, 1.6 squared, plus 4.2 squared, 1.6 squared equals 4.2 squared plus x squared minus 2 times x times 4.2 times cos 18. Okay, so we've got 1.6 squared, 2.56 plus 4.2 squared. Two times 4.2 times cos 18 minus 7.9888 x. Okay, so altogether, you put this all on one side, 0 equals x squared minus 7.988887x, 17.64 minus 2.56 plus 15.08. Which means we can find x using our formula is minus b, so that's 7.9887 plus or minus the square root b squared, which is 7.9887 squared, minus 4a, which is 1, times c, which is 15.8, all over 2a, which is just 2. 7.9887 plus square root 7.9887 squared minus 4 times 8 divided by 2 296. Or we do the minus 1, 7.9887 minus the square root 7.9887 squared is 4 times 3.059. So x is one of those two values. And then we want to work out the area of the triangle. So the area is half AB sine C, so it's half 4.2 times and given that it's obtuse, given that PQR is obtuse, well, let's work it out with 3.059025 sine C, so sine 18. So half times 4.2 times 3.0590 times sine 18 is 1.98511. I make 1.99. If I was to use the other one, half times 4.2 times 4.9296 sine 18 is 3.19899. So if this is bigger, this would make the triangle over here, so it would be an acute angle. Okay, so this one is not the right answer. Okay, and you've got to go with this one. Now, interestingly, the Bank scheme says it rounds to 1.98. So there must be a little bit of rounding error in there, but if you've done this, you've got the right working. Okay. So 24. Particle P moves along a straight line that passes through a fixed point O. Displacement from X is that given. It's given by that. The direction of motion reverses when p is at the point A on the line. The acceleration of p instant when p is at A is given by that to find the value of A. Okay, so first of all we want to differentiate it to find the velocity, and we're going to find the velocity, so dx by dt is 12t squared minus 27, and it reverses, so at that point the velocity is 0. But let's just do, so this is the velocity, then the acceleration is, differentiate the velocity again, so it's dv by dt, let's just do that, is 24t. But we want to find when v equals 0, 12t squared minus 27 equals 0, so t squared is 27 over 12, so t equals square root of 27 over 12, which is 3 over 2. Can only be the positive because we've got positive time, and then at that point the A is 24 times 3 over 2, which is 12 times 3, which is 36. Okay, 25. Function is this. With domain equal to this, that means the input values are that, express g to the minus 1 in the form that. So the first thing we've got to do is we've got to rewrite it. So we've got to go 5 plus 6x minus x squared equals y. So we've got to rearrange that, and the way to do that is to complete the square on that. So that's going to be let's multiply it all through by minus 1, so we get x squared minus 6x minus 5 equals minus y, so we get x minus 3 squared, that's minus 6x, so we've got a minus 9 minus 5 equals minus y, so x minus 3 squared equals minus y plus 14, so x minus 3 equals the square root of 14 minus y, so x equals 3 minus square root of 14 minus y. Now we've got to rearrange it, so I know that y equals 3 plus minus square root of 14 minus x, swap the x's and the y's. Now we know that the domain x has got to be bigger than 3, so we know that it's got to be the positive square root. So it's in the form 3 plus minus x. State the domain of this. Well, this is only valid when x x has got to be less than or equal to 14, otherwise you end up taking the square root of a negative number. Okay, and then we're on to final one. Our arithmetic sequence has the first term a and a correlating difference of d, where d is a prime number. The sum of the first n terms of the sequence is Sn. Sm is 39 and S2m is 320. Find the value of d, the value of m, show clear algebraic working. Okay, so we know that n, the number of terms, so m over 2 2a plus n minus 1 d equals 39, and we know that 2m over 2 2a plus 2m minus 1 d equals 320. Okay. So we can simplify that down, kind of get rid of the fraction. So we've got the first one becomes 2 ma plus m minus 1 d equals 2 lots of 39, which is going to be 78. 32ma. Yeah. And then this one is just 2ma, so these two go, plus m 2m minus 1 d equals 320. So I'm just going to get rid of, I'm going to subtract one from the other. And so that gets rid of the a's, so I get let's multiply this out. I can't do this in my head. So the top one becomes 2ma plus m squared d minus md equals 78, and this bottom one becomes 2ma plus 2m squared d minus md equals 320. So if I just subtract them, this one take the bottom one, take away the top one, the only thing I'm left with is an m squared d, and 320 take away 78 is 242. And we know that 242, I split it down, is 2 and 1, 2, 1, which is 11 and 11. So the only way that this can work, given that d is a prime number, is d must be 2, and m is an integer, so m must be 11 and d must be 2. Okay, and there we go. Now finished the paper. Hope that was useful.